a Doppler effect. And then, so the equation of Doppler effect, yeah, FL equals to V plus or minus VL over V plus or minus VS times F. So meaning, give fraction U times the F. So the FL, the frequency of the listener. So that's what we'll be calculating most of the time. We're going to calculate the frequency of the listener. That is FL. And then FS is the frequency of the source. However, when the ambulance efita, and then oyemiti lemon ambulance efita. Anything efananka sound is the source. So however, FS frequency of the source. Work ambulance. Ambulance is the source of the sound, and when oyeming, you are the listener. Or it might be that ofeta, bila ambulance eyeming. Ambulance, it's still the source. Kopakuli yamaponesa. When yamaponesa ends in sound, it's the source. And when you are the listener. So umoto amameting that sound. So frequency of sound, it's measured in hertz. You will always be given the frequency of the source. So batla of the hertz, Hz, 1000 Hz. It's always the frequency of the ambulance, but I'll blella. To answer you with FL, in hertz as well. So Fs is the frequency of the source, measured in hertz, and then V is speed of sound in medium, measured in meters per second. So that V will be maybe sound of the air. The sound of the air. So that V stands for the sound of the air. And then VL, not the sound, sorry, V is speed of sound in medium, measured in meters per second. So it might be the air, not the source. And then VL is speed of the observer, listener, measured in meters per second. So if the listener is standing still, that means the speed is 0 for the listener. Or let's say the source is standing still and the listener is the one passing the listener who's standing in a stationary position. Stationary position, how you miss still. They're in a stationary position. So whoever is standing when the whole thing is happening, speed is 0. But if the person is walking, would matter of a velocity. So that velocity stands for speed. And then for VS, speed of the source, measured in meters per second. So you must know that the source of the noise or of the sound would have a speed in which they are traveling in, and then you will use it. But if the source is standing still, then the speed of the source is 0. And then, so Doppler expressions to use after writing Doppler effect formula. So you have that formula, which is FL equals to V plus or minus VL over V plus or minus VS times FS, right? So this is how you use it. You are going to use the plus or minus sign depending on the relative motion of the source and the observer, depending whether the observer or the source is standing or walking. So when the source is moving towards a stationary listener, meaning the source, the ambulance, is moving towards a standing person who is standing in one place, maybe if it is delaying, you're just standing by the side of the road waiting for it to pass. That means the listener is in a stationary position. So we're going to take FL, which is the frequency of the listener, equals to V, which is speed, over speed minus the speed of the source, multiplied by the frequency of the source. So that's how you're going to calculate a stationary listener. When a source is moving towards, so you are standing in a place, starting maybe at a junction, and then the source, the ambulance, is moving towards you. That is the formula you're going to use, the first one. So keep the source moving towards, a standing still listener. So it's FL equals to V over V subtract VS times FS. So yeah, pele formula, it's for the source that is moving towards a listener, I mean still. And then the second one, when the source is moving away from the listener. So the source it turns towards the opposite direction. Yazama. This is when the source is moving away from a stationary listener. So when the source is moving away, on the first one, the sound is approaching the one who's standing. So the sound is approaching, is getting louder, approaching to the stationary listener. And then on the second part, the sound is moving away from the stationary listener. So Kimo modulo is a plus instead of minusing the denominator, which is V plus speed of the listener. So you add them. Remember that difference. And then in the exam, they might just give you this one, formula with bonum. So you have to know how you use it. Those plus and minus is just an indication of you use subtraction. How is a you use minus when it's a. So when the sound is approaching a stationary listener, it's minus. But when the sound is moving away, meaning the source is moving away from a stationary listener, it's plus. So when the listener is moving towards a stationary source, now is the listener, and the source, which is the ambulance, in a siren that is ringing quite loud, it's standing, and you are moving towards this ambulance. Maybe it's at a crime scene, you are moving towards it. So that V plus VL now goes on top. So the frequency of the listener, when the listener is moving towards a stationary source, is FL, frequency of the listener, equals to speed plus speed of the listener over V times the source's frequency. So that's what you always have to know, that when the listener is moving towards a stationary or a standing still source, those plus and minuses are on top. So V plus VL, they are on top. So for a listener moving towards a stationary source, we use VL, and then that is speed of the listener. But because the listener can are moving, but when the source is moving and the listener is standing still, we use the speed of the source. And then when the listener is moving away from a stationary source, so you minus. Whenever something is moving away, it's a minus. Whenever something is approaching, it's a plus, whether is the listener or the source. And what you have to know, what goes as a denominator, when does V goes as a denominator. And then we have an example here. Another thing is that there are instances where both the source and the listener are not moving. They are both at a stationary point. So when the listener and the source are in a stationary point, you are going to take V over V times Vs. So it's going to be speed over speed multiplied by the source's frequency. And what you have to know, if only frequency source illegally frequency listener, if they are both standing still. So you are standing next to an ambulance which is making noise with the siren, meaning your frequency and the frequency of the ambulance is the same at that particular point. So both the speed of the listener and the speed of the source are 0. So more is V, which is speed, minus 0. V minus the listener speed, I guess speed of the air minus the listener speed. Now it's 0. So the listener speed remains the same, and then on the bottom you're gonna have that speed of the air, and then it's also gonna subtract the source speed. So source speed had means still 0. So you're gonna have the speed of the air. In this, let's look at this example. Both the source and the listener are stationary, meaning they're standing still. So the siren of a stationary ambulance emits waves at a frequency of 800 hertz. That is the frequency of the stationary ambulance. So it emits waves of a frequency of 800 hertz. So that 800 hertz, it's the frequency of the source. Fs is 800 hertz. So determine the frequency of the sound heard by a stationary observer if the speed of sound in air is 340 meters per second. So you see the FL, that's what we're looking for, and then the stationary the source frequency is 800 hertz, and then the speed is 340, and then the listener's speed is 0, and then the source speed is also 0. So which means we have V over V, that is 1. 1 times 800 is going to be equals to 800 hertz. So FL and FS are the same. Now, when the source and the listener are stationary, the frequency observed by the listener is the same as the frequency of the source. Now, the source is moving towards a stationary listener. The source is moving towards a listener, means still. So an ambulance is moving towards a stationary listener with a velocity of 30 meters per second. So the velocity is the speed. They're giving you the speed of the source. And then the frequency emitted by the ambulance is 600 hertz. So that is the frequency of the source, which is Fs, 600. But I calculate the frequency that the listener will detect. If the speed of the sound in air is 340, that 340 meters per second is the V. So you substitute everything into the equation. You say 340, which is the V, over V, which is 340, minus the speed of the source. Because is the source moving towards, or is the source moving away? It's not the listener. If it's the listener, you use the speed of the listener, and they will give you the speed of the listener. And then here we say the source is moving away from a stationary listener. So an ambulance is moving away from a stationary listener with a velocity of 25 meters per second. Whenever they say velocity is the speed of the source or is the speed of the listener. But in this instance, it's an ambulance, so it is the source. The frequency emitted by the ambulance is 450 hertz, that's Fs. Calculate the frequency that the listener will detect if the speed of sound in air is 340 meters per second. So you have everything. And then let's see the frequency of the listener. The listener, because it's moving at a stationary point, the speed is 0. Yes. So let's do the last. The listener is moving away from a stationary source. So let's say a police car is in attendance at an accident scene. The police car is stationary and its siren is emitting a sound of frequency of 1000 hertz. A taxi is traveling towards the accident scene at a velocity of 23 meters per second. So the taxi, which does not have a sound, a siren, is the listener. So in America, speed is at 23 meters per second. And then the police car is stationary and its siren is emitting a sound of frequency of 100 hertz. So the Fs, the frequency of the source, is 1000 hertz. Calculate the frequency of sound heard by the driver of the taxi when moving towards the scene. The speed of the air is 340, so that is the V. And this is the solution to that question. And something grade 10 that you have to know is that frequency, that F, frequency is 1 over time. That's how you calculate frequency. So 1 over time. So grade 10, examination guidelines, by beta waves and sounds. So the frequency, when referring to sound wave, frequency can be referred to as the pitch. For example, a sound wave with a higher pitch means the sound wave has a higher frequency. So frequency is calculated by the total number of waves divided by total time, or F equals to 1 over T. So 6 waves passes a point in 4 seconds. Calculate the frequency of the wave. So the total number of waves is 6 seconds. Where is 6 waves pass a point in 4 seconds. So that's over 4. That's 1.5 hertz. If they ever give you these things and they don't give you frequency, whatever you remember, it's the listener or the source. And then period is the time taken for one complete wave pulse. So the SI units for period is seconds. So formula for period is total time over number of waves. So it's a flip, frequency. Time is the opposite of frequency. 8 waves passes a point in 4 seconds. Calculate the period of the wave. So 4 seconds of a time and the number of waves goes at the bottom. So kitty seconds yon. And then there are wave speed. The wave speed is the different distance traveled by a point on a wave per unit time. The speed of wave measured in meters per second. Formula for period, V is the speed, and then F is the frequency, and then T is the wave length. So I'm gonna show you the wave length. Yeah. Wabana mo bangozing 30 centimeter sorry, that is the wavelength. So mo bangozing a that line on the left side, the vertical line, it'll be an number, so you will know how long is the wavelength. So that is how long the wavelength is. So that is the wavelength. That's what we'll be trying to calculate.